This is Cam and Chan's video summary of our experiment for Physics 122. The purpose of our experiment was to prove Bernoulli's principle of fluid dynamics and to find the relationship between a drain spout's velocity and position compared to the container's velocity and position. And with all that, to derive an equation for drain time. Our equipment consisted of 2 milk cartons. One was a 1 quart, the other a 2 quart. And to measure the water levels in each container, we had a motion sensor. For the cartons, we poked some holes into them using a soldering iron. We had 2 types of holes. Ones were small holes, the others were big holes. On the bottom we had one small and one big. On the side we had, on the low side, we had 1 small hole and 1 big hole, and on the high side, kind of in the middle of the carton, we had another small hole and a big hole. We then taped all the holes we weren't going to use, and then covered the hole that we were going to use for our experiment with our finger, and then filled up the carton up to about, I think, 1.35 centimeters from the top with water, and then let it drain under the motion sensor. We would then record the data from the motion sensor into a graph, and then have the computer form a quadratic equation out of that, which we can derive its velocity and acceleration that way through its position. One problem that occurred was the small carton was too skinny for the motion sensor to detect the water level properly, because when it got to a lower level, it started picking up the side of the milk carton, and that deemed all of our data worthless pretty much at that point. The procedure for the bottom holes was simple. We just covered the hole and just let it drain under the motion sensor, and just let the computer do its work. And but for the side holes, we also had to measure the position of the spout, the water spout. By what we did was we took a ruler and we laid it on the bottom of the table, and then just sort of played it by eye. And I would record the time that it took to get 1 centimeter lower from the other. And so from all that, we just extracted all the quadratic equations that were produced from the experiments, and plugged it into Mathematica and analyzed it from there. So some, but not all of our results correlated well with the principles of fluid dynamics and Bernoulli's law and conservation. What turned out really well was our position graphs. It does exactly what it's supposed to do, which is start draining real fast and then slowing down over time. And with that, we were able to get a pretty accurate representation of its velocity and acceleration. But on the other hand, it didn't correlate at all with the derived formulas we came up with for time, though that could be completely wrong. But also, as mentioned in class, viscosity and depending on the shape of the hole plays a role into it, one that actually makes a big difference, apparently. Our data on our spout position was also way off. For the law of conservation, the velocity of the inside of the carton times its cross-sectional area should equal the cross-sectional area of a spout times its velocity, and well, that didn't turn out quite as it should have, but that probably had to do with the fact that we were playing it completely by eye. We probably should have used a camera to gauge that, but but we learned from it. And so that is our project summary.